This video is going to show you the solution to one of the example problems in kinematics. When the space shuttle returns to Earth, it can experience as much as 7.8 Gs. If the space shuttle endured this acceleration while changing from 75,997 meters per second to 51,657 meters per second, then how much time did this part of the journey take? Well, to begin with, I'm talking about the motion of an object. There's no forces or anything else, just the motion. So that means I'm dealing with kinematics. I'll look for some unit clues. I know that it's 7.8 Gs, so that's an acceleration. And specifically, it's a deceleration, so it's going to be slowing down. I'll have a negative sign somewhere. And its speed's changing from 75,997 meters per second, so again, a unit clue about velocity, to 51,657 meters per second, again, another unit clue. And the 75,000 happens early in time, the 51,000 happens later in time. So the initial is going to be the 75, the final is going to be 51. And I'm looking for time. So that's the variable I'm after in all this. So I'll list my givens. I look at my unit clues and I see the 75,000 is the beginning, that's initial velocity. 51 is the end of the motion, that's the final velocity. And acceleration, well, it tells me that it's decelerating. So because it tells me it's decelerating, I'm going to make it a negative 7.8 Gs. But I got a problem. All this isn't in SI units, so I need to convert the Gs over into meters per second squared. So I'll make a little statement about what I'm doing, converting from Gs to meters per second. And I'll say negative 7.8 Gs. Using dimensional analysis, I just multiply, or basically replace the letter G with 9.8. So multiplying by 9.8 meters per second squared, and that gives me negative 76.44 meters per second squared. Notice the negative signs are still there. They didn't go away. Now it looks like I know I have what I need. So my next task is, because I'm talking about the motion, use kinematics to find the time for the change in velocity. So the final velocity is equal to initial velocity plus AT. So I went through this process of elimination by looking at my variables, V0, V, A, and T, and finding the formula that would fit that relationship. So V equals V0 plus AT. So I put the final velocity in, 75,997 meters per second is equal to 51,657 meters per second, plus a negative 76.44 meters per second squared, times the time. Solve it for the time, and I get 318.4 seconds. Alright. So if I was grading this, what am I looking for? In my list of givens, I'm looking for a variable number, signs, and units in all the givens. That's what I'm always looking for in all the givens the entire year. Okay, that's part of the communications process. So I need to see that you're able to understand what's in the problem and show me you understand what's in the problem. Next, I have this twice actually, a statement describing what you're trying to accomplish. So convert to G's from meters per second squared and find the time for the change in velocity. Those two are the statements describing what I'm trying to accomplish. You can see it appears twice. Formula with only variables, that's the V equals V0 plus AT. Formula with numbers and units, you can see that. And then finally, an answer with units. Now, if you're wondering what your paper looks like, your paper would look something like this. So this is what your notebook paper would look like. You can see how it's organized in a nice column. If you need to, you might start a second column, but everything starts in the top left and goes down. If you want to, you can think of columns of newspaper going down left and then down again on the right if you need more space. And when I shrink it down, you can see that it only took up a small piece of the whole paper.